Hello everyone. In today's lecture, we're going to be looking at the equations of uniformly accelerated motion. We're going to be looking at how we can use these four equations of motion to solve problems related to uniformly accelerated motion. But first, let's identify the meaning of the symbols written there, where U represents the initial velocity, V the final velocity, A acceleration, S the distance covered, and T the time taken. And of course, we know that the SI unit of velocity is meter per second. The SI unit of acceleration is meter per second squared. The SI unit of distance is meter, and that of time is seconds. So let's go into the problem proper. Now in this question it says a car takes off from rest and covers a distance of 80 meters on a straight road in 10 seconds. So the first thing we need to do is to bring out the parameters given in the question. Now the parameters are like the values used to describe a given system, the values used to describe a given system. But in this context now, we're looking at those values given in the questions that will help us solve or tackle the problem itself. So those values are the parameters, and that's what we're going to bring out first. And it says that a car starts from rest. Since the car started from rest or starts from rest, we can say that the initial velocity u is equal to 0 because it started from rest, and then it covers a distance of 80 meters. Distance, which is represented with symbol s, equals 80 meter, covers a distance of 80 meter on a straight road in 10 seconds. The time is equal to 10 seconds. And we are told to calculate its acceleration. So the acceleration A is unknown. So what we need to do now is to look at the four equations of motion and to identify the most suited equation to solve this problem, the best fit equation to solve this problem. And how do we do that? You can see from thorough review, you can see that from this third equation, we have our s for distance, we have our u for initial velocity, we have our t for time, we also have acceleration and time also. So which means that this third equation is best fitted. The equation that has all the parameters given in the question represents the best or the most suited equation to use. We have s corresponding, we have u here, we also have u here, we also have acceleration, we also have the time and time here. So without further ado, we'll say that we're going to use the third equation. And from the third equation, we have that s equals ut plus half at squared. Now, all we need to do is to substitute these values into the equation. S is equal to 80 meters, so in place of s, I have 80 equal to u is equal to 0, so in place of u, I have 0 bracket the time 10 seconds plus half. Then the acceleration is unknown, so I'm going to leave it the way it is. The unknown is usually left the way it is. Then the time 10 seconds. 10, remember to put the square. So this becomes 80 equals 0 times 10, of course, is 0, plus half. 10 squared is 10 times 10, and 10 times 10 is 100, so I have that bracket 100a. So 80 equal to, we see that 100 divided by 2 is 50, so I can have this as 50a. Then to make a the subject formula, or to calculate finally for a, we need to divide both sides by the coefficients of a. We need to divide both sides by 50, and when we do that, we have that therefore a is equal to 80 over 50. And when we punch our calculator, we have that 80 divided by 50 is 1.6. Now I can't leave my answer that way. I need to put the units, and the unit we have there is meter per second square. So the acceleration is 1.6 meter per second squared. So in my next video, I'll be solving the second question we have here. Thanks for watching, and remember to subscribe to my YouTube channel.